Hi everyone, this is Aaron Larson, Executive Editor of Power Magazine, and you are listening to the Power Podcast. On today's episode, I'm joined by Alexina Jackson. Alexina is the Vice President of Strategic Development with AES Corporation. Thanks for joining me, Alexina. Can you please tell a little bit about yourself and what you do with AES?
Yeah, thank you very much. So I am in AES's innovation business. We have three key business areas. AES is a renewable energy developer. We are also a utilities business. And then, as I noted, we are an innovation business as well. So within the innovation business, I lead a team of really bright individuals who are thinking day in and day out about how we evolve our electrical grid to be more modern and better meet the needs of our customers, who ultimately are the reason that we have an electrical grid.
I came across a white paper that AES had put together, and it's on smarter use of the dynamic grid. And I know you've put out another recent white paper. Can you talk a little bit about what would be the focus for these papers?
We at AES are very excited about these technologies, which are generally referred to as grid enhancing technologies, or GETs. GETs are exciting to us because they are technologies that help us unlock quickly the additional headroom or additional capability of the grid to carry energy across the system. This is something that is very important because today we are not making the fullest use of the electricity system as it's built for very good reasons, for reliability. We make sure that we aren't always running the grid at its full capacity. But once we have these technologies, such as dynamic line rating, which helps us visualize the dynamic and full headroom of the electrical grid, and then technologies like storage as transmission, advanced power flow control, topology optimization, they all allow us to operate the grid in its dynamic capability. By doing both these things, visualization and operation dynamically, we're able to start making fuller use of that carrying capacity for energy, which will allow us to add additional energy more quickly, serve our customer needs more efficiently, and ultimately decarbonize faster.
Yeah, you talk about doing it quickly. I know when new transmission needs to be added to a system, it can take years or even decades, 10 years to get some of these projects approved and actually finished. So how can these other technologies like dynamic line rating help make that process of adding new generation to the grid easier?
That's absolutely right, particularly when we're talking about high voltage transmission lines. These are ones that may travel for long distances, need wider rights of way, and you might be anticipating, therefore, require more land and may pass through more communities, may pass even between states, and therefore cross state and federal boundaries. In this way, because of that complexity, permitting can result in a considerable delay in building these assets, let alone the actual construction of these large towers themselves. And this delay, which is common when we're talking about adding new energy like renewable energy, because you often have to carry the energy from where it's produced, where there's good wind, where there's good sun, to where it's consumed. And so this delay on the building of these transmission assets is really significant. So things like dynamic line rating are extremely effective on these high-powered, high-voltage lines. What dynamic line rating would do in this instance is it shows you what is already available on the line. What it does is it puts a sensor combined with software to be able to measure the full capacity of that line to carry energy. And then with that visibility, you're able to make better decisions about when the carrying capacity is available, when to move energy across the system, and thereby make better use of the system. And in our experience, the dynamic line rating deployment was very quick. We were able to deploy in a series of months from the idea of wanting to deploy a dynamic line rating to actually getting it on the grid. And 6 months later, we were able to start thinking about, okay, what is it that we're seeing about our grid? How might we choose to maintain it, operate it, plan it differently? And so that's a really quick turnaround. Doing anything on the grid in less than a year is really significant when it comes to transmission.
Sure. And I believe the company you worked with was Line Vision. I think there's others out there that are doing similar type of work on dynamic line rating. I know EPRI has done some testing also with Line Vision. How did you get connected with them, and were you happy with the collaboration that you had?
Absolutely. Yeah, there are a number of really good dynamic line rating organizations out there. We connected with Line Vision through National Grid. They actually have their own activities going on trying to build coalitions of utilities in order to make technological change in the grid. So thank you, National Grid, for helping connect us. And then once we were connected with Line Vision, we really liked that their technology has a couple of key components that are covered in the white paper you referenced earlier. One of them is that it is a sensor that is mounted on the poles or structures themselves. So we didn't have to take outages to mount the sensor. We could just put up a couple of ladders with our existing trained technicians, and with some at height fall protection, they were able to quickly, in less than 30 minutes, install sensors and start getting data from the field. So we liked that safety component quite a lot. We also really liked that they were using LiDAR technology, which specifically gives you not just awareness about the line itself, but the actual situation, the trees that might be encroaching, how the line is moving in space. That visual awareness helps actually understand the carrying capacity, as well as measures that you could take to improve the carrying capacity of the line. There were also a number of other features that we liked, like the ability to potentially expand additional sensors within the same footprint, the ability to move the sensor if we decided it would be better used elsewhere. We really believe that flexibility is a key to the future dynamic grid. And also we like their NERC-CIP compliant approach to security and cybersecurity.
Now, another solution that you mentioned in the opening was storage as transmission. Can you talk a little bit about that and how that works?
We're really excited about storage, of course. AES has been an original storage fan and did a lot of work to get it out there in the field. And storage as transmission is just another evolution in storage's capabilities. In fact, I like to say that it would be great to let storage bring its full self to work, because it has a lot of talents that we're currently underusing. And in fact, we tell storage that it has to either be energy or maybe a transmission asset. And we're not currently realizing its full capacity of being able to do both from the same device. So that's the challenge we hope to solve. But storage as transmission specifically helps as a suite of these quick to deploy and relatively inexpensive dynamic technologies, because you can actually use that dynamic nature that I was saying. There might be better times to have energy travel across the line. With that knowledge, you can actually send energy, preferably renewable energy, but any energy across the line when it is abundant, and then store it in a storage device closer to load where it can be consumed when it's needed. So if you imagine it as a battery at either end of a potentially constrained line, you can store energy at one end when it's being produced, when the sun is shining and when the wind is blowing. And then when there's space on that transmission line, you send it and you store it on the other side of the line, close to where it's going to be consumed. One way to think about that might be as an effective warehousing and logistics solution, or you might also think about it as an Airbnb for the grid, where you can make sure that the resources that we have in the system are being used effectively.
It's really a cool idea and something that it hadn't occurred to me in the past. So this is a new option, I think, for probably many of our listeners as well. What about topology optimization? What does that mean, and how do you do that?
Sure. Topology optimization today is really focused around switching so that the energy can flow based on physics across lines that are less constrained. And so just imagine, it's obviously not as simple as this, but for people to understand clearly, you're turning on or off a light switch so that you can allow energy to flow or not flow across the line. And so there are studies that can be done, analyses that can be done to say if we're seeing constraints on a line or we're seeing certain potential for overloading other lines, we can make decisions to actually change the flow of energy across lines to make better use of them. As I was saying earlier, if dynamic line rating is the visibility into the dynamic flows, topology optimization would be taking advantage of that visibility and changing the switches on and off so that the energy flows in the most beneficial way.
And then the last one that I think you mentioned was the advanced power flow control. How does that work, and where would you utilize that best?
Sure. I'd commend everyone who wants to get into the details of the technical power systems engineering to one of our white papers. I'm not going to step outside of my depth on that. But certainly advanced power flow control is also like the ability to make those decisions about where to flow energy. Instead of using switches, it actually changes what's called the impedance on the line. So if you imagine energy like water will flow where there's less resistance to it flowing. And so you can actually change the impedance to say, flow on this less constrained line, don't flow on this more constrained line. And so it allows you to push or pull energy in certain directions through its physical properties so that it goes in the direction that you prefer to see it go.
Now, it sounds as if, the work that AES has done has kind of proved that all of these are very beneficial to the grid. So what do we need to do in order to get them implemented in more places throughout the grid and improve the situation?
Well, one key thing we need to do is education. And so that's one of the reasons why we put our white papers out there and we're sharing our insights at a system level. We want to make sure that we're breaking down barriers to people's understanding of these technologies. So we're very excited that anyone listening to this podcast might be learning a bit more about them and be able to see them deployed more broadly on the grid. So education is extremely key. We also need to see deployments. And so our deployment of dynamic line rating is one of, we hope, first of many proof points that we can bring to the system. But those deployments are going to help people understand not only conceptually, but actually in the field, how these technologies can be done, how they perform, things to watch out for, things to make the most of, so that we can move from those early deployments into scale. And so finally, to achieve that scale, to get that integration of these technologies as just basic building blocks or basic tools in the toolbox of how we plan, build, and operate our grid, we have opportunities, obviously, for ambitious and innovative utilities to go first or second and lean in, but also the opportunity for policymakers to help us overcome what are often called in business switching costs or menu costs. It's not easy to make change. And if you think about the economic structures that utilities have, as well as just the big job that utilities already have to keep the grid that's in place safe, reliable, and affordable, we need to help people educate themselves, take the time to learn how to add these new technologies into the existing system, understand how it may add or change to software systems, control systems, all of those details, those operations sorts of costs, and then get it so that these technologies can be just another part of the capital base that utilities profit from.
I'm thinking about this as a nationwide project, but are there certain regions where this is going to be more important than others? And are there certain ISOs or RTOs that are really embracing this more than others?
You definitely see a lot of use cases in certain ISOs. There are other use cases from technology providers, for example, in SPP, or I mentioned National Grid. They've done some great work. And we're really excited that in our own utilities, we're doing work in MISO and PJM, and we're excited to have conversations in the future about operationalizing our DLR deployment, for example. So I think what's helpful to keep in mind is that topology on the grid matters, and that means that you need a number of tools in the toolbox. DLR, advanced power flow control, topology optimization, storage, they are not going to be the singular solution in every case. So just like when you're working on your house, you might need a hammer for one thing and a wrench for another. These tools are part of a toolbox, and you need to look at what the need on the grid is in a certain instance, what the electrical characteristics are of that grid, and then choose the right tool for the job. DLR, for example, fantastic in windy areas. And so as you look throughout our nation where there is good wind, you'll probably see a lot of DLR. And so I think it's a combination of both the utilities being ready to do the work, the ISOs ready to receive it, and finding the right tool for the job.
Yeah. And that DLR example is kind of important, too, because a lot of places where there is wind, there's a lot of wind turbines. So it makes sense that would be a benefit to help move that power where it needs to go.
Agree. It's a good match.
All right. Well, again, for listeners, I've been speaking with Alexina Jackson. She's the Vice President of Strategic Development with AES Corporation. Is there any last words or anything that we haven't talked about that might be important for listeners to know?
I'm very excited for other utilities to join in the deployment of these technologies. There's a lot of opportunity, both benefit to customers, benefit to the utility, and ultimately benefit to the transition for all of us to serving up the energy we need to maintain economic growth within our country and decarbonization of our system. So let's not leave this value on the table. Let's get out there and get it done.
All right. Well, thank you so much for sharing your insight and sharing your time. Thank you.
Appreciate it.